Okay, hello everyone in a new video. So we have reached part 11 of chapter 7, which is the chapter of Newton's second law for grade 11 students. In this one we are going to solve exercise number 15. They are telling me a football player shoots a ball from the ground with a velocity of magnitude v0 is equal to 20 meters per second. Now notice that in this case this exercise is obviously projectile motion because it's launched with initial velocity v0 making an angle alpha with the horizontal. So let me write here that v0 is equal to 20 meters per second and that alpha is equal to 50 degrees. So whenever these two are specified and the origin here we have that x0 is equal to 0 and y0 is equal to 0, then the system is completely determined. Now neglect the resistance and take g is equal to 10 meters per second square, which means that we are performing this experiment on the surface of the earth. Now in number 1 they are telling me derive the time equations of the center of mass of the football, consider the shooting point as the origin, which means that x0 is equal to 0 and y0 is equal to 0, of the system xoy and ox as the ground. Okay, so whenever they tell me derive the time equations, we know that the time of equations of the projectile are given by x is equal to v0 cosine alpha t plus x0, y is equal to minus half gt square plus v0 sine alpha 0t plus y0. So here it's not alpha 0, it's simply alpha. So these are the time equations of the center of mass, but whenever they are telling me derive, we need to derive them, okay? So let's start. So always whenever we need to derive the time equations, we need to start by Newton's second law, which is given by apply Newton's second law for the football. Which is given by sum of forces is equal to ma. Now at any instant here, the ball is submitted to the weight because the air resistance is being neglected. Now we are interested in the projection along the y, which is equal to minus w, which is pointing in the negative direction, and wx is simply given by 0. So let me say that projection, so w is equal to ma. So projection along the x-axis, so simply we drop down the vector quantities. So let me say first projection along the y-axis. So we drop down the vector quantity and each vector quantity will carry the label y. So in this case we have minus mg is equal to may, which means that ay is equal to minus g. So here we have that ay is equal to minus g. Why minus g? Because simply the weight is pointing downward and the positive y direction is upward. Now as for the projection along the x-axis, we have that wx is equal to max, but wx is 0, and knowing that mass is different than 0, so we have that ax is equal to 0. Okay, so in this case ax is equal to 0. Now as an acceleration vector, this is equal to axi plus ayj, so this is 0 and this is minus g. So now yet we didn't derive the time equations, but it's important to indicate the acceleration, because whenever we know the value of the acceleration or find the acceleration, now we can determine the type of motion along each of the axes. So notice that because the acceleration along the y-axis is constant, so it's u/v/m, and along the x-axis it's 0, it's u/m. So let me say motion along the x-axis, and let me say since ax equal to 0 verifies the general form, a equal to 0, then the type of motion is URM along the x-axis. So now we can use the following equations that are given by x is equal to vxt plus x0. So recall that these equations are the equations of the URM equations, and each quantity derived from a vector quantity will carry a label. So Vx is equal to a constant and Ax is equal to 0. Now in order to determine these equations completely, we need to determine Vx, x0, so okay. Now in this case this is 0 because simply this is taken as the origin. Now Vx is equal to a constant, which means that this quantity can be determined by considering any instant, and in particular because we know the value of V0 and we know the value of alpha, then simply V0 can be determined, Vx can be determined by the initial instant, which is 0, so this is equal to V0 x because it is constant. Now what does V0 x represent? Recall that V0 is the magnitude of the V0 vector, which is equal to V0 xi plus V0 yj. So this is determined from the projection. So what's the projection of V0 along the x-axis? It's pointing in the same direction, which is positive, so it's plus, and its magnitude is given by V0 multiplied by the cosine of V0 and x, which is alpha, so it's equal to V0 cosine alpha. So in this case, simply the time equations for the x direction are given by x is equal to V0 cosine alpha t plus x0, so this is 0. Vx is equal to V0 cosine alpha, and Ax is equal to 0. Okay, and let me write them down here. And now let's do the same for the motion along the y-axis. So as for the motion along the y-axis, so let me say since ay which is equal to minus g verifies the general form, which is given by a is equal to a constant or ay is equal to constant. Now here notice that they are naming the angle to be alpha and not alpha 0. For this reason I'm using alpha and not alpha 0. Then the type of motion is UVRM along the y-axis. And in this case we can use the following equations. Y is equal to half ayt squared plus v0yt plus y0. Vy is equal to ayt plus v0y, and ay is equal to minus g. So in this case we already know the value of ay, which is minus g, so this is minus g, and this is minus g. Now it's left to determine v0y, because this is 0. As we did for the x component, the v0y is the y projection of the initial vector along the y component, so it's pointing in the same direction, so v0y is equal to plus v0. If this is alpha, this angle here is pi by 2 minus alpha, so v0y is equal to plus v0 cosine pi by 2 minus alpha, which is equal to v0 sine alpha. Okay, so in this case the y equations can be written as y is equal to minus half gt square plus v0 sine alpha t, vy is equal to minus gt plus v0 sine alpha, and ay is equal to minus g. So it's a good habit whenever we are deriving these equations not to replace any values and to keep them in the form of an unknown. So in terms of later on we will replace values. So now, because v0 is equal to 20 meters per second and alpha is equal to 50 degrees, so cosine alpha in this case, okay, so v0 cosine alpha is equal to 20 multiplied by cosine 50, which is equal to 12.86. So let me directly write them in that way. So x is equal to v0 cosine alpha t is given by, to avoid writing units, so vx is equal to 12.86 meter per second, and ax is equal to 0. As for the other equations, y is equal to, so this is minus 5 t square plus v0, which is 20 times sine, so this is plus 15.3. Now vy is equal to minus 10t plus 15.32, and ay is equal to minus 10 meter per second square. Okay, so this is it for number 1. So as you can see that previously in chapter 6, in chapter 5, the chapter of kinematics, we used to consider the following equations. Now, for example, we can construct the position vector, we can determine the magnitude of the speed, instantaneous speed, we can determine the trajectory. So these are governed by Newton's second law. We are determining this equation using Newton's second law. Now in number 2, they are telling me determine the equation of the trajectory, and here I want to say something that's very important. Now the equation of the trajectory is a relation between x and y. Now we have these relations that are in terms of numerical values and the relations that are in terms of unknown. Whenever we want to determine something, it's better to use these equations because we have dealt with them using the course. So, and we can make sure that if our answer is correct or wrong, then after doing so, we will plug in numerical values. So now we are interested in determining the trajectory. So we say that x is equal to v0 cosine alpha t, which means that t is equal to x divided by v0 cosine alpha, and we know that y is equal to minus half gt square plus v0 sine alpha t. Now replace in y, so y is equal to minus half g into x divided by v0 cosine alpha to the power 2 plus v0 sine alpha multiplied by x divided by v0 cosine alpha. So v0 simplifies with v0. Now y is equal to minus half g1 divided by v0 square cosine square alpha multiplied by x to the power 2 plus tangent alpha x, because sine over cosine is tangent alpha. Now because we are talking about the trajectory, here we need to mention the shape, and we know that the shape of the trajectory is parabola in the case of projectile motion. So in this case this is parabola. Why it's parabola? Because simply linear in one variable and quadratic in the other. Okay, now we are ready to replace some values. We have that v0 is equal to 50 meters per second and alpha is equal to 50 degrees. So, and we know that the value of g is given by 10 meters per second square. Now, what's the benefit that working in terms of unknowns, or to determine this expression before we replace? Now, because we know that we have seen this previously during the chapter, and we know that this expression is completely correct. Okay, now we can replace some values. So y is equal to minus half multiplied by tan 1. So here we have 5 to the power 2 cosine, 50 times cosine 50. I think v is given by 5 or 50. v0 by 20. Times cosine 50 to the power 2 plus tangent 50 multiplied by x. Then the equation is given by y is equal to, now plugging this expression on the calculator, we have minus 0.03 x square plus tangent 50, which is given by 1.19x. So this is the equation of the trajectory. Okay, so this is it for number 2. Now in number 3, determine the maximum height of the projectile. So the maximum height is the point, this point, which is the peak, and the peak is dictated by which equation? Notice that in this case the velocity is completely parallel to the x-axis, which means that vy is equal to 0. So always the maximum height is dictated by the following formula: vy is equal to 0. Okay, so vy is given by minus gt plus v0 sine alpha, and at the same time we need that vy is equal to 0, which means that minus gt plus v0 sine alpha is equal to 0. Now here notice that we are interested in determining the maximum height, which is this height. In order to determine this height, we are interested in determining the value of y, which is given by this. But in order to determine the value of y, we need to determine the value of t. Okay, so from this equation we will determine the value of t, which is given by t is equal to v0 sine alpha divided by g, which is equal to, so the value of v0 is given by 20 meters per second, I think. So 20 multiplied by sine of 50 divided by tan, which is equal to 1.53 seconds. So now after we have determined the value of t, we can replace in this equation in order to determine the value of y. So now the maximum height, which I will denote by capital H, so h is equal to minus 5 t square plus 15.32t. Now instead of the value of t we will replace this time correspond for what? For Vy is equal to 0. Why Vy is equal to 0? Because at this point we have the maximum height. So plugging this on the calculator, then the maximum height is given by 11.74 meters. So maximum height is given by 11.74 meters. So we are done with parts 1, 2 and 3. They are telling me define the range. So we need to define the range and of the projectile, then calculate its value for the projectile, for this projectile. So I just want to use the same definition that I have used in the explanation. So okay, so we need to define the range. So what is the range? Is the horizontal distance, just 1 second. Is the horizontal distance between the shooting point and, so I think it is the, I'm trying to remember the exact definition. So let me let me open the definition. Let me open the flip chart that contains the definition. So the range is given by the horizontal distance covered by the projectile is the horizontal distance covered by the projectile between the shooting point and the point of intersection with the horizontal line so with the horizontal line passing through the shooting point. Okay, so this is the definition. Now graphically, the range corresponds to the distance between the horizontal distance between the shooting point and this intersection point. So this is the range and the range. So we are determining the value of x. In order to determine the value of x, we need to determine the value of t, because notice that this is a horizontal distance. So in order to determine the value of t, so notice that in this case the value of y is given by 0. So now referring back to this equation and setting y is equal to 0, so y, which is equal to minus 5t squared plus 15.32t is equal to 0. Then minus 5t squared plus 15.32t is equal to 0. Now taking t as a common factor, so what's the type of this equation? This is a quadratic equation in t. We can solve it by two methods. Either we solve for delta, discriminant delta, or by factorization. So here we can, for example, simply factorize. Taking t as a common factor, we have minus 5t plus 15.32, which is equal to 0. Now t is given by 15.32 divided by 5. Then the value of t in this case is given by 3.06 seconds. So now this time, this instant time, it corresponds to the instant where the projectile hits the point A. So this instant t is equal to 3.06 seconds. And notice that we have calculated the instant at which the projectile reaches maximum height, which is given by 1.53 seconds. Okay, and notice that this time is greater than this time, and actually it's the double. Okay, so in this case we know that our answers are correct. Now after we have determined the value of t, we are interested in determining the range, and the range is the horizontal distance, which is OA. Now referring back to this equation, which is x is equal to 12.86 multiplied by t. Now 12.86 multiplied by the time t, which is 3.06, plotting this on the calculator, then this is given by 39.35 meters. So the range, which is denoted by capital R, is equal to 39.35 meters. Now let's move on. So we are done with part 4. They are telling me which vector B, C, or D in figure represent the resultant force applied on the ball at point M. Justify. So here at the point M during the trajectory, we have three vectors that are represented. We have the vector C and the vector D and the vector B. They are telling me which of these three vectors represent the resultant forces. Recall that we are in part 5. So the resultant of the forces, which is sum of forces, is simply equal to the weight. Weight is the only force acting on the football. And the weight acts vertically downward So in this case, the correct vector is C. Then C corresponds to W, since it has the same line of action and direction. So we are done with part 5. Okay, and I think let me eliminate these questions from this video. So let me eliminate these questions. And let's consider only that this exercise consists of the first 5 parts, okay? So that's it for me in this video, guys. In part 12, we will complete solving exercises on this chapter.